Hey creators, it's me, RobotDiva. Motors may give robots their muscles, but what good are muscles if you can't sense the world around you? That's where sensors come in. Sensors are what make robots aware, responsive, and even creative. Today, we're going to explore the sensor subsystem, the part of robotics that makes your creations come alive. Without sensors, a robot is like a person walking blindfolded, bumping into things, repeating actions without really knowing what's happening. With sensors, robots can see, hear, feel, and respond. Sensors are a robot's eyes, ears, and skin. They transform raw motion into intelligent behavior. One of the first distinctions we make in robotics is between active and passive sensors. Active sensors send something out and measure what comes back, like ultrasonic sound waves, LiDAR lasers, or radar beams, just like a bat using echolocation. Passive sensors simply listen. A light sensor measures brightness that's already there. A microphone hears sound without sending anything out. Active is like shouting into a cave and listening for the echo. Passive is like quietly listening to birds in the morning. Another way we classify sensors is by what they sense. Proprioception means sensing yourself. In robots, that's encoders tracking wheel turns or gyroscopes balancing. For humans, it's knowing where your hand is, even with your eyes closed. Exteroception means sensing the outside world. For humans, that's vision, hearing, touch, taste, and smell. For robots, it's cameras, microphones, and distance sensors. Together, proprioception and exteroception give awareness of both me and the world. Not all sensors are created equal. Engineers care about a few key properties: range, how far it detects; resolution, how detailed the measurement is; accuracy, how close it is to the real value; response time, how fast it reacts. It's like choosing a camera. Do you want zoom, sharpness, true, color, and no lag? Sensors face the same trade-offs. We can also classify sensors by the kind of signal they produce. Analog sensors give continuous values, like light level, temperature, or how much a flex sensor bends. Digital sensors give discrete values, yes or no, on or off, a button pressed or not, an IR brake beam blocked or clear. Analog lets us measure ranges. Digital is binary, true or false. Both are powerful, and they're the bridge between the real world and computer logic. Robots and humans sense the world in similar ways. Eyes become cameras, ears become microphones, skin becomes touch sensors, noses become gas detectors, tongues become chemical sensors. But here's the exciting part. Robots can sense what we can't: infrared, ultrasound, magnetic fields. Sensors begin with human inspiration, but they can extend far beyond our natural senses. One sensor is rarely enough. Robots often use sensor fusion, combining multiple sensors for a clearer picture of the world. Self-driving cars use cameras to see lanes, LiDAR to map distance, radar to measure speed, and GPS to track position. Together, they make smarter, safer decisions. Humans do it too. When crossing a street, you don't just look, you listen for cars and feel for the curb. That's fusion in action. And sensors aren't just about safety or precision. They're also about expression. A sound sensor can make a robot dance to the beat. A touch sensor can light up an art installation. A camera can trigger interactive art that responds to people passing by. That's why STEAM is so powerful. Sensors let robots become creative partners, not just machines. Here's a fun fact. Early industrial robots had no sensors at all. They followed pre-programmed paths, repeating tasks without awareness. Adding sensors changed everything. Suddenly, robots could adapt and interact with their environment. Today, NASA's Mars rovers are packed with sensors: eyes, ears, skin, even noses and tongues, exploring a planet we've never set foot on. That's the power of sensing. Motors may be the muscles, but sensors are the nervous system. They give robots awareness and adaptability. Our bathroom buddy isn't just a toy. It follows lines, avoids obstacles, and signals with LEDs. All of that is powered by sensors. You're surrounded by sensors every day, your phone unlocking with your face, your car's parking assist, even the little fridge light. Now, when you build with us, you'll know how to give your robots their own senses too. I'm RobotDiva, and I'll see you in our next video, where we put sensors into action with the Bathroom Buddy build. Don't forget to like, subscribe, and visit STEAMDivas.org for deeper tutorials, diagrams, and code. Because in robotics, sensing is believing.